Hey everyone, just gonna set things up a little. Move myself down here. Let me make sure everything is running smoothly. Give me a sec. Okay. Um, Today I'm gonna try and learn. Oh, hold on, let me hide this. I think you could see my. Hide this. I think you can see my screen now. Just make sure. Okay, so today we're gonna go try and solve some deep ML questions. We're gonna generate a uh, deep zero question for Monte Carlo simulation. I'm just gonna try and learn. I don't know why Monte Carlo simulation always sounded cool to me. I think I understand the basic idea. Basically, uh, you sample from a distribution continuously until you get the probability distribution. So you just flip a coin a bunch of times, and you'll see how many times you need to flip the coin. How much times? I'm not explaining this well. Let's get started, and then I'll work through it. So let's generate the question. This could take about 2 minutes-ish, so we could start off on something simple. Let's just try out a sigmoid question. Oh, my generation has failed. Let's try that again. Let's stay on the page just to make sure it's not an issue with leaving the page, but it shouldn't be. But yeah, Monte Carlo simulation. It has such a cool name to it. Um, I think you're just simulating an event happening a bunch of times, and then, like, theoretically, you could simulate a stock market moving by taking the average. Let's like, so in my mind, you have stock market, and you're gonna have some. So let's say this was event one, and you take this was like the history, and we'll say this is a cutoff point. So we have this history, and we're learning from this, and we create some mean and variance, and then we basically come up with a bunch of possibilities. Come up with a bunch of possibilities based on that mean and variance. So we're basically random sampling, and then hoping that I guess the average mimics the average here. I mean, that's my current understanding. Yeah, but I need to obviously do a lot more research in this, and hopefully, yeah, there we go. Monte Carlo simulation for approximating pi. Okay, so let me zoom in here. Implement the function to estimate the value using pi using Monte Carlo method. Okay. Random point square. Okay, this sounds fun. So basically, we have a square, and we need to determine the proportion of time. So we're generating numbers within a unit square, or just a square within a square. Determine if it falls within the unit circle instead of the square. So let's draw a little image of that. So we have a square, and we have a. I don't think I'm gonna get this exactly right, but we have a unit circle in here. Unit circle just means, I think the diameter or the radius is one. I don't think I mean, we'll see if it matters a lot later on. Um, Accept integer parameter, number of samples, okay. NumPy random number generator. Okay, so we have to use NumPy, we can't just use random. This I'm a little confused by, because it says NumPy for random number generator and distance calculation. Does NumPy have a distance? Nope. Does NumPy have a distance calculation? I mean, it probably does, but like, we'll look into that later when we're programming this. Constant number of samples. Okay, and should return an estimate of pi. Okay. I mean, oh, I guess this is an example, so we're theoretically our function will go for 100 iterations, generate 100 random points, and determine the random points within a square and determine the proportion. Weird. So it's basically saying if I have a bunch of dots randomly generated within this square, I understand these aren't dots, some of these are lines, whatever. Basically, oh, hey, it's way too big now. It was a little too small before. Okay. And then it's basically saying if we take the proportion of dots within the circle divided by, I mean, the amount of in the circle divided by the total amount, you would get an estimate for pi. That's interesting. Okay, let's try and learn. Blah, blah, blah. Okay, doesn't look so bad, but let's see. Okay. So, I guess Monte Carlo simulation is just estimating something using random sampling. Okay, so basically estimating pi through, so I guess it's useful when you don't have a formula for something and you just want to keep on random sampling. I guess it approaches the correct answer the more samples you do. Okay. Okay, so yeah, we start with a square with a circle inside like we have here. Okay. So we're saying this has size 2. Okay, we're gonna let me make this smaller. Let me make this 100. Okay. That's getting me annoyed. And let me let's do large. Okay, so that's 2. Length 2. Square 2. Centered at the origin. Okay, so theoretically, this would be the origin. This would be -1. This would be 1. Something 2 up here. Or put 2 here. Make a bad squiggly. Yeah. I'm not gonna do a bad squiggly thing because I'm not good at drawing. But yeah, theoretically. Theoretically, this is equivalent to 2. Okay, but it's both by the x and the y-axis, so it's the same thing for the y-axis. We're just showing for the x one with a unit circle within it. Find a set of points where the distance from the origin is at most 1. Find a set of points where the okay. There's a set of points where the distance from the origin is at least Okay, so it's the radius is 1. Change to black. So this is 1. Oh, and that makes sense because this is a circle supposed to be touching the box. Oh, this looks really nice. Okay. I didn't think this would come out so nicely looking. Okay. People probably watching this and be like, what do you mean nicely? It looks terrible. So I'm just like, I'm doing my best. Okay. Um, the area of the square is 4, which is 2 times 2. That makes sense. Okay, yeah, the area of the circle is pi r squared. With radius equals 1, yeah, that's what we said. So it just equals pi. So we have square. We said equals 4. And we have circle, whatever, equals pi. Okay. So the ratio of the circle to the square, okay, that makes sense, is 4 divided by pi because we're saying, yeah, the area of this is pi, the area of this square is 4, so, oh wait, it's pi divided by 4, right? Yeah, pi divided by 4. So we're saying the proportion of the circle to the square is pi over 4. That makes sense. The ratio of the circle and area, the square. Okay, the ratio forms the foundation of this. Okay. Okay, so I guess here's the main part. So we're saying if we randomly generate, uniformly random generate from -1 to 1, and -1 to 1 to generate a point, so it's generating 2 points, we would get, so yeah, so basically this, so we would get, so we're basically trying to estimate pi. I guess this makes sense. I like this. Um, so however many points drop in here versus here, we're basically estimating, I guess, this proportion right here, because we know, I guess this is 4, but we don't know pi. So let's see what we do. Would we have to, I have some ideas about this, but let's see. Okay, to estimate the ratio using kind of 2. Okay, yeah, we're gonna have to estimate, we're gonna have to generate an x and y coordinate. Yeah, uniformly from -1 to 1, that makes sense. Okay, so up here it didn't really say the distance metric. Here it's telling us, okay, Euclidean distance. Why do I need the distance? Maybe to, oh, okay, okay. So we need, I guess visually this is just like, oh, you see if it hits inside the circle or outside the circle, but I guess in reality, how do you actually know if something's within the circle or not? So you just take the Euclidean distance from, I guess the point, what point would this be? This would be 0, 0. So testing from 0, 0. Let me make a dot. So 0, 0, if it's more than, you know, 1 away, if the Euclidean distance is greater than 1, it's in the square. If it's less than, or what if it's less than or equal, whatever, less than or equal to 1, it's not ever going to be exactly 1. It is within the circle. Here D represents straight line distance from the point to the center of the square. Okay. Yeah, I think that's what we were saying. Yeah, if it's less than 1, it's within the circle. If it's greater than 1, it's outside of the circle. Okay, once you have the large number of points, we calculate the proportion. Circle, that makes sense. N be the total amount of points sampled, K be the number of points within the circle, and N be, okay. This proportion estimates the ratio. This to find pi, just multiply times 4. Okay. Okay. I think I know where, okay. Seems pretty straightforward. Let's see. Let's go to notebook mode. Let's see. I don't know if I remember. Rand? I don't know if I remember. Uh, Uniform? Okay. I think I got it. Okay, that will generate a single random number. I'm assuming there's a size, so if I do 2, nope, that did not do what I wanted it to do. Let me just look up the documentation. Yeah, I don't need ChatGPT, I could use Google. Do it the old-fashioned way. Okay. Low, high, size. So theoretically we want from -1 to 1, and this, let's say just put 10. Okay, that will just make 10. Let's say I did 10 by 2. So this would theoretically be 0.1, this would be 0.2, and so on. Okay, we'll call this points. Let's see what that looks like. I'll just do the Euclidean distance myself, even if there's a numpy function for it. What was it? It's x squared plus y squared. I wonder if there's a nice way to do this matrix-wise. I'm assuming there is. So I take the transpose. Would this be what I want it to be? It could be the other way. Yeah, definitely not that. Okay. So we basically want to take x squared plus y squared. So we want to square all these values. Sum them together, but not by that access. So this should have length of 10, and then we'd want the square root. Square root of this, give us the distance values. Okay, so here we had, okay, this is really not such a bad problem. It sounded scary, but relatively fun and easy. So it seems like we did 10. This was, seems like 9 out of 10. So it would be 4 times 9 divided by 10. 3, wow, huh. It's crazy that this estimated pi even relatively close. Even just with 10 samples, we got 3. Let's check on something. Okay. I think we're ready to solve this. Let's see. Let me make sure. NumPy is imported. This should be num samples by 2. Yeah, that makes sense. This should be our distances. Okay. I really do enjoy learning this way. I'm a little biased because I made this. It feels like I just made a tool for, I made a website for myself, and I keep trying to make it better and just to help myself learn. It just feels like a selfish thing, but I guess it's also useful for other people, so I'm happy that other people also like it. Um, I don't know, to me, like self-studying is tough without something like this, just because I always run into the thing like I read something and I'm like, oh, I know it, and then I don't really know it. Like I feel like if I just read a blog post about this, I would somewhat understand it, but I feel like implementing it from scratch really, make sure you understand it. Also, even like before I did DeepML, I would just program it by myself, but I felt like I just never knew if I was correct or incorrect. Or like, so it's nice having a, this site to make sure, and a little bit of a community. We're building up the comments and everything. Where were we? So basically this D. We can just do this. Where D is greater than or equal to less than or equal to 1. That'll be a 1, else 0. And then we would sum, divide by, in our case, 10. And then times 4. Yeah. So then we take this, our distance, we will return 4 times the sum where D is less than that, divided by number of samples. Let's see how I did. I got them all wrong. Oh, okay, fine. That's what I get for not naming things the same. I got them all wrong again. Um, expected, actual. Okay. I mean, I'd say, okay, maybe there is a numpy, because it says here, use the numpy random number generator. Which makes me, this could be an annoying question, just because let me first try to, I'm thinking right now, um, it could be numpy dot random and just generate a number from 0 to 1, just that, I don't know exactly the numpy function that does that, but that function then multiply times, oh, I guess, I was gonna say multiply times 2, I don't know, let's hope it's not that option, let's hope it's just, I need to use their distance calculation. Let's hope it's just this. Where did I get my distances? Let's go to notebook mode. Let's change this up. Instead of this, we want between our points. We want to know the distances. Probably this. Okay. Let's see. So if I change our distances to use this, will it work? It still doesn't work. Am I missing something? I feel like I'm not missing something because, I mean, I mean, my answers are close. My output's a little closer here. Which makes me think they might just be generating the numbers differently. Because we should be generating from -1 to 1, and from -1 to 1. That's what we're doing. We're getting the distance. If the distance is less than 1, less than or equal to 1, it's within the circle. Else 0. Oh. No, yeah, we're summing those values up. 4 times that. Yeah, I don't see where I went wrong. And 4 times the sum of this divided by number of samples. That shouldn't matter, okay. Let's check out the solution. Let's see what they did. So I don't think I'm doing anything wrong. Okay, they're generating an x point and a y point. Getting the distance. Okay, they're checking if the distance is less than or equal to 1. And then taking, yeah, number of points within inside the circle. I feel like we're doing the same thing, unless, I mean, I feel like this is the biggest difference. So I'm going, I mean, oh, oh. Okay. Yeah, so so I did everything right. It just they generated 2 random numbers, and these generating these 2 random numbers separately instead of the way I did it. You're probably gonna get a different set of points, just because randomly generating them. But if I theoretically did, yeah, if I did this, take a distance. So I'm doing everything right. It's just yeah, dealing with random numbers, and I guess generating a question, dealing with random numbers. And it now specifically telling you generate point X and then generate point Y. It's probably going to mess things up. This is going to give me an or whatever, it's gonna get everything wrong. Yeah, I knew that. Okay. I really should add a button to cancel your run for instances like that, just to save you guys some time. Oh, yay. Okay. Okay, so I'd consider that as me getting that correct. Just a small, yeah, it just didn't know how we were going to generate random numbers, and it doesn't specify it. So, yeah, I mean, I enjoyed the question, definitely learned a lot from it, and even though there was, I guess, a bug, just it still helped me understand Monte Carlo simulation. Now I want to try. Let me. Let's see, Monte Carlo simulation for stock prediction. Hope I spelled everything right. The more you watch, the more you realize I have no idea how to spell. Just fair warning. The hardest part about programming is definitely spelling. I mean, not really, because I only need to memorize, 5, 10 words. And then people need to deal with my terrible spelling by reading my documentation for stuff. Okay. Let's see. So, yeah, our goal is to learn Monte Carlo simulation. I feel like this was a nice, easy question to just understand the core idea behind it. Write in the comments or the live chat if you want me to solve something else. Right now I'm going to try and solve Monte Carlo simulation for stock prediction. We'll see what kind of question it generates. Let's see. But I only have like probably 10 to 15 minutes, so I don't know if I'm going to actually fully solve this, but I will do my best. Let's see. Oh, nice. Monte Carlo simulation for asset pricing path. That sounds pretty interesting. I wonder if we're going to run into the same issue of, generating the random numbers. Yeah, we're definitely not going to get through this, but we will try. Yeah, see, this seems like a more interesting use case of Monte Carlo simulation. I think it's used a lot in option pricing, but I could be mistaken. Okay, let's see what it wants from us. Let's see. The moment that generates. Yeah, so geometric Brownian motion. That's what they used for option pricing. It's a really good book. I think Man of All Markets, talking about how he created black, or yeah, it sounds like he created Black-Scholes theory before Black-Scholes created it, and he traded based on that model and did quite well for himself. And that's just basically how to price options. Options are, stock market things. I won't get into that now. The function should take it on. So, initial price. Okay. Drift coefficient, mu. Not 100% sure what this means, but I'm sure we'll learn about it in the learn section. Sigma, volatility coefficient. T is the total time period. N is the total number of step. Okay. So T is total time period. Positive number is the number of time steps. Okay, so T is the current time, and N is the number of steps we want to take into the future. And number of simulations, the number of simulations we want to run. Okay. Get some information here. Okay, so let's draw. I think I was actually explaining to start with. So we'll just go back here. So let's assume this is a stock. And this is like known, and then this is unknown, and we're trying to estimate, the path of, the expected path of the stock, uh, given some, I think it was like mu s0 sigma blah blah blah. So let's just label this so we understand where everything lies. So I think S. It's really in. Okay, let me make this smaller and then zoom in. Okay. Hope everyone really likes my bad drawing. Okay, so maybe no, it's not. I mean, I guess I drew this mostly by hand. So this is S0. This is, I guess, the price at, time step t. So mu, not 100% sure. Sigma is the volatility. So let's say we have sigma, and I'm assuming sigma we're going to derive from the past. We'll say, I don't really know. Okay, whatever. We know what sigma is. Sigma is the, we need to get a pen or something. This is, this is annoying without that. Okay, so this, so the, sigma is the volatility. I wonder why they don't use standard deviation. Okay, whatever. Mu we're still figuring out. Sigma we got. T the total. Okay, so T should be right here in my current understanding. And then N is number of time steps in positive integer. Okay. This is N. This is the, or this is N. It's total number of time steps. I'm not gonna make a bunch of these because that's annoying. But whatever. Okay. And number of simulations is number of colors, I guess. So yeah, that's how many simulations we should do. So theoretically, the more simulations we do, the more it will converge to a proper value. Like we learned before, the more samples we took with the circle, just estimating pi through a unit circle and 2x2 square, the more random dots we put in there, the higher the accuracy of the estimation of pi is. So I guess the same hope is here. Basically, if we sample this a whole bunch, we'll become closer and closer to the true movement of the market or the stock. Okay. Yeah, so we need to learn what Brownian motion is, because to be honest, I'm not sure. I know it's used, but I don't know exactly what it is. Okay. So it's, I'm sorry. Used to describe random behavior for stock price over time. Okay, doesn't really tell us much. Okay, so assumes the stock works on a specific type of random walk. Fine. So it's basically saying just, okay. I guess it's just a random, I don't know, we'll continue reading. Before I get into it, incorporate both a predictable trend and an unpredictable fluctuation. I wonder if it would be beneficial to, like, let's say you trained, I was gonna say if you trained a model and to make these predictions, would it do better than Brownian motion? Because it sounds like Brownian motion is just a way of predicting, making a simulation. But I wonder if, yeah, we're not going to solve this, but in this amount of time, yeah, I have like 5 minutes. So instead of this, I'm going to say how I would want to solve this. So it sounds like Brownian motion. I'm assuming there's a set formula for it. Geometric Brownian motion model is given by whatever this. Okay, first was a logarithmic return of the stock can be approximated as. Okay, yeah, this can be an interesting question, but maybe I'll do it next time. Um, so I guess my question is, instead of doing this to or whatever the estimate for each one of these lines is, or however we generated it, if we had, I don't know, I feel like it'd be interesting if we just had a model. I think everything is in terms of data science and machine learning. If we had a model that takes in, let's say we have our squiggly line, and we'll say this is the training data, and then we might have a bunch of stocks, so it wouldn't just be one. This way we'd actually get a decent amount. Okay, so we had a line here. Okay, so let's say we trained a model, and then we made predictions based on that model. But I guess that, I guess the issue there would be we would get a single prediction. Like we would just get one prediction out of this, even if you ran it 100 times, and it's not really using. So, I mean, I guess it's not really using Monte Carlo simulation. It's just using a model to predict the outcome. Or, I mean, I wonder if it would do better, just even just that. But let's say we wanted to. Yeah, I wonder if that would just do better. I'm assuming not, but I was also thinking, let's say you added a little, so let's say we're here. Uh, let's say we just added a little noise to right before the input. So basically, it would be, so we have our model. We have current price. Move this over. And I want to basically do current price, or current, whatever the input to this model is, plus some noise. And then feed that into our model. And that will give us a prediction. And we could run this, 100 times, 1,000 times, whatever it is, each time changing the noise parameter. And this would probably, I mean, I don't know if there's a point of this, but would probably give us, a different set of results. Like I'm saying, it would create, like, because we're changing up the input slightly, then the question will become, what do you change, what do we do, like how do we compute the noise that we want to compute? I mean, it'd probably just be a standard deviation. Or we could look at the past data and say, like, what's the average daily growth and what's the average standard deviation, or yeah, and just use that to generate some normal noise based on that, and add that to the current price. But does this make sense? And then I'm just trying to think, does it make more sense just to let it do one prediction and use that as the main prediction? Like, are we just estimating? Like, if I do this a million times, is that just estimating, the main prediction? Which it might. Um, Interesting though. But I guess if I for whatever reason want to use Monte Carlo simulation through this method, I guess that works. But yeah, we're currently using. Oh, maybe it'll be a fun project to estimate Brownian motion success rates. Like I'm saying, how well it actually predicts. Is that what we're trying to do? I guess. And I guess right now that's what we're trying to do. Yeah, we're trying to predict multiple paths the stock could take, and then averaging those, assuming averaging those, and getting to the final result. Okay. Current price, noise. I really think, I mean, I don't know if this actually would be beneficial or not, but it's interesting. I wonder if you could just make a model that would predict the market better and then theoretically trade or option price. Because I don't know enough about option pricing to be honest to be talking about this, but you could use that as an input to the option pricing model instead of the Brownian motion, stock prediction. Probably missing something. Sorry I wasn't able to complete this question today. Maybe we'll do it a different day. Maybe we'll work on something else. But I do. Again, I am biased because I made this, but I do like this tool to be able to study. It just lets you create questions and solve those questions. I know currently it's only for premium users. We're trying to work out the pricing, so we could at least give everyone some free questions. Um, but we did make every question anyone generates public, so you could go to DeepML, go to Deep Zero, and solve any of the questions that are currently available. Or, to be honest, you could probably just tweet me and be like, oh, hey, can you generate this question? I'll be like, sure thing. Uh, if you don't want to get the premium subscription. I think that's it for me today. Have a good day, everyone.